Welcome to Fire Sprinkler Systems. In this presentation, we'll cover sprinkler systems and the code regulations governing them. In this module, we will review installation, inspection, testing and maintenance of sprinkler systems. We will also discuss sprinkler system components, what to look for during inspections, and required maintenance for sprinkler systems. Conducting periodic inspections, testing, and maintenance will help to ensure the sprinkler system will work as it was designed. There are 4 types of sprinkler coverage. The type of coverage the building has depends on the occupancy classification and the code in effect at the time it was constructed. Here is a basic photo of a fire sprinkler system. Water comes into the sprinkler system past the static and residual pressure gauges. The static pressure gauge indicates how much water pressure is coming in the system. The residual pressure gauge indicates how much pressure is remaining in the system after water flows through a sprinkler head. The water travels to the main control valve. There are many types of control valves, which will be explained in later slides. The water then travels to the alarm check valve or flow switch. The flow switch is not shown in the diagram. The alarm check valve and flow switch sound a local alarm indicating water is flowing through the system. The riser carries the water up into the cross main. The cross main carries the water to the branch lines, which carries water to the sprinkler heads. The main drain releases water from the system for maintenance purposes. The inspector's test valve is located at the most remote portion of the sprinkler system and allows a qualified inspector to conduct tests to ensure the water flow alarm activates within 45 to 90 seconds. On the inlet side, the fire department connection allows fire department to pump additional water into the sprinkler system. The check valve ensures water flows in only one direction. In this portion of the presentation, we'll explain sprinkler system components and discrepancies to look for. Control valves shut off water to the sprinkler systems. They're also called indicating valves, as they have a physical feature that indicates whether they are in the open or shut position. Detailed descriptions will be given in the following slides to help identify indicating valves. Backflow preventers prevent water from flowing backwards into the street side supply. This one has an outside stem and yoke design, commonly called OS and Y. When the stem is outside, as in the picture, it indicates the valves are open. If the stem was not visible, it would indicate the valve is closed. There are 2 valves in case one fails. When properly installed, the stem valve is in the upright position. When conducting an inspection, look for excessive corrosion anywhere on the valve. The tamper switch and conduit should be intact and without damage. Backflow preventers are equipped with fire department connections, also known as FDCs. The caps shall be in place. Remove the caps and ensure the gasket is inside. Turn the swivel and ensure it moves freely. All parts should be clean and free of corrosion and debris. Be sure to replace the caps after inspecting. The backflow preventer shall have a sign stating which addresses it serves. These photos are of the same backflow preventer from different perspectives. Note the caps are on the FDC, the chain and lock are in place, and there is no evidence of leaking or corrosion. These photos depict post-indicator valves, also known as PIVs. With this indicator valve type, look at the sight glass on the front to determine the valve's status. In the photo on the left, the valve is open. In the photo on the right, the valve is closed or shut. In the photo on the left, the cover for the tamper switch is missing. In the photo on the right, the J-box has detached from the conduit. It is important to note that chains and breakaway locks are not required when there is a tamper switch installed, as in these photos. In these photos, the signage indicating the buildings served is appropriately placed. Also note the sprinkler bell in the photo on the left. It's properly labeled with a type of alarm and instructions to call 911 when sounding. Note that 3 feet of clearance is required to all sprinkler system components. This PIV is obstructed. The vegetation will need to be removed. These are wall-mounted control valves. They perform the same function as the control valves on the previous slides, and as such, have the same requirements. Signs indicating the building served posted on or near the valves, and chains with breakaway locks are required. Again, there should be no corrosion or leaking, and no exposed wires. Butterfly valves have paddles that are parallel or in line with the riser indicating it is open. The requirements for signs indicating area served, chains, and breakaway locks are the same. The tamper switch and associated connections must be intact. All components should be free of leaks and corrosion. As the name suggests, fire department connections allow the fire department to infuse additional water into the sprinkler system, which boosts the pressure to the fused sprinkler heads. FDCs are required to be labeled indicating which buildings they serve. FDC caps must always be in place and no debris inside the inlet. Gaskets are required to be in place and in good condition. Couplings must swivel freely. In this photo, there is no gasket and no cap. If caps are not in place, the interior of the connection shall be inspected for obstructions. When debris is present, the inlets will need to be backflushed to ensure there are no obstructions. Codes require a fire department connection shall be backflushed every 5 years. As with other sprinkler equipment, visibility and access to FDCs is required. This is a sprinkler alarm bell. It sounds when water is flowing through the sprinkler system. The bell is required to be labeled with instructions to call the fire department or police when the bell rings. Sprinkler alarm bells are only required when the system has 20 or more sprinkler heads and may be locally or centrally monitored. These photos show examples of two types of sprinkler risers. Risers may be located outside or inside the building. The following slides detail the items inspected on the sprinkler system. If fire sprinkler risers are located inside a room, a sign on the door to the riser room is required. Keys for the door shall be located inside a key box. Access to all fire protection equipment is required. Nothing of any kind shall be stored within 3 feet of all sprinkler equipment, including the riser. Visually inspect the gauges. They should be in good condition and readable. Check the pressure and compare it to the calculation card. In the photo on the left, there is pressure indicated on the gauge. In the photo on the right, there is no pressure in the system. Hydraulic nameplates for hydraulically designed systems shall be inspected quarterly to verify that it is attached securely to the sprinkler riser and is legible. Labels indicating the 5-year certification date shall be used on water-based fire protection systems. The label or tag shall be securely attached to each automatic fire extinguishing system at the time of service. Cover plates and conduit are required to ensure the alarm wiring will relay signals to the fire alarm panel. In this photo, the conduit is intact, but the cover plates are missing. All valves are to be clean and in good condition. Corrosion may keep this shutoff valve from operating. All sprinkler systems are required to have a box with spare sprinkler heads and a wrench. The sprinklers shall be representative of the sprinkler heads currently in use in the system. Look at the sprinkler piping, hangers, and bracing. They should be in good condition and free of corrosion. All bracing and hangers shall be securely attached. In this photo, the hanger is damaged and the sprinkler head is corroded. Both need to be replaced. The weight of the water inside the pipe may cause it to break. Sprinkler system piping and hangers are usually centrally located to allow the sprinklers to be in prime locations. There is a tendency to attach items to these components. At no time shall any sprinkler system component be used to support non-system items. Grounding of electrical systems is not allowed. Covers for recessed sprinkler heads will release and allow the sprinkler head to drop out at a certain temperature. The deflector will drop down and water will disperse over the protected area. Covers should be replaced when missing or painted. In the photo on the right, the sprinkler cover is missing and will need to be replaced. The sprinkler head in the photo on the left is corroded, and this will cause it to malfunction. The bent and obstructed sprinkler head on the right will not protect the area being covered. Storage is not permitted within 18 inches below the level of the sprinkler head deflector. The storage around the sprinkler head will disrupt the spray pattern and cause the system to not function as designed. Deflectors of sprinkler heads shall be aligned parallel to ceilings, roofs, or the incline of stairs. When sprinklers are subject to mechanical damage, they shall be protected with listed guards, also called cages. Sprinklers shall be installed under fixed obstructions that are over 4 feet wide, such as ducts, decks, open grate flooring, cutting tables, and overhead doors. Sprinklers shall be installed under exterior roofs or canopies exceeding 4 feet. When the canopy or roof is of non-combustible construction, sprinklers can be omitted. When combustibles are stored and handled under roofs and canopies, sprinklers shall be installed. When installed in open car garages, within 20 feet of building openings, balconies, and patios, sprinkler heads shall be listed for corrosion resistance, such as Teflon or wax-coated or stainless steel. When sprinkler heads fuse, the water inside is under tremendous pressure and can cause the piping to rotate when there is space between the branch line and the bracing. Surge clips are installed to hold the pipe in place. Periodic maintenance is required on all components of the sprinkler system. Monthly, quarterly, and annual inspection, testing, and maintenance, as well as 5-year certifications are required on all fire sprinkler systems. Records of testing and maintenance must be kept on site. Any changes to the structure, materials stored within the structure, the use of the structure, or processes or materials within the structure change, the fire protection system in the building will need to be reevaluated and changed as necessary.